Hello everyone, welcome to wireless networking series. Guys, today in this video we are going to discuss roaming process. Roaming process means how a client machine connects from one AP to another AP, or in other word you can say how a client machine move from one AP to another AP automatically, right, without any disturbance. Let's suppose this is my scenario, and guys, in my scenario I have only one AP here, that is AP1. Suppose this AP is transmitting signal in this coverage area. This is the coverage area of AP1. So AP1 can transmit signal in this area, that is guys BSA, geographical area of one BSS, right, BSA1. So this AP is transmitting SSID, this AP is transmitting BSSID, means MAC address, as well as this AP is transmitting their capability, right, with the help of beacon signal. In last class we discussed two types of signal. One is beacon signal, let me write it, beacon signal, and another one is probe signal. So we discussed these two types of signal in previous video. AP beacon signal is transmitted by AP and probe signal is transmitted by your client machine. My client machine means PCs are sending probe signal and AP is sending beacon signal. In the beacon signal there will be some information like SSID, BSSID means MAC address, right, and their capabilities. So actually access point is transmitting SSID, BSSID means their MAC address, Wi-Fi network name, and their capability, means what features this access point is supporting. Then client machine is sending probe message, probe signal. Now question is, why access point is sending beacon signal, guys? To represent wireless network. Like in this area this AP is transmitting signal, that means this AP is representing wireless network in this area. So any client machine or any wireless devices can get connected with network with the help of this AP if that device is inside this area, this BSA. Okay, so in last video we talked about these two types of signal, beacon and probe. Beacon signal is sent by AP access point to represent wireless network, and probe signal is sent by client machine to discover the access point, right? Because let's say this client machine have entered in this area. Now this client machine don't know where is the AP, right? So it will send probe message to discover the AP. Again, there are two types of probe signal. One is probe request and one is probe response, right? So probe request is sent by client machine and response is sent by access point. So let's say if this PC don't know the AP, then this PC, this client machine will broadcast the probe message, probe request message, and if this client machine knows the AP, then it will send unicast probe message, and that probe signal is going to carry again SSID because my client machine already know the access point. So this client machine have information that what is the SSID of my access point, and destination MAC will be the MAC address of access point, that is BSSID. So if a client machine knows the AP, then it will send unicast probe message. If client machine don't know the AP, then it will broadcast the probe message. Beacon message is used by AP to represent the wireless network, and probe message is used by client machine to discover the access point. So let's suppose this PC have discovered the access point, guys. This client machine PC1 have discovered the access point. Now to connect with this AP, my client machine is going to send association message, So we discussed these messages in last class, right? These signals in last class. Today we are going to discuss roaming process. So with the help of association message, my PC1 is connected with this AP. Now in the same way, guys, I have one another area here, let's say this area. And in this area also I have one AP, that is access point 2. And this AP is also transmitting same SSID, right? This is BSA2. So AP2 is transmitting same SSID in BSA2. Now if this client machine want to move from this area to this area, what will happen? See, when this client machine will move in this area BSA2, it will get a stronger signal from AP number 2. In this area it is getting a stronger signal from AP1, that's why it is connected with AP1. But if this client machine will move in this area, then it will get a stronger signal from AP number 2. So whenever a client machine will move from one BSA to another BSA, how it will shift the AP automatically, that is known as what? Roaming process, and that we are going to discuss today in this video. Okay, so in last video we discussed how a device machine can connect with access point, and today we are going to discuss how a client machine can move from one AP to another AP. Now guys, without wasting our time, let's begin. We'll also see some basic configuration of access point today in this video. Okay, so see the roaming process. Guys, first of all, initial connection. If you don't know the initial connection means how a device and device can connect with AP, then watch my previous video. Okay, so initial connection means an employee's device connects to the network. It associates with the nearest AP identified by its BSS ID. So how a client machine is going to identify AP, guys? With the help of MAC address, that is BSS ID, the unique MAC address of the AP. Then continuous scanning. See, if a device is connected with one access point, like in my scenario, this is my access point AP, and here is the client. This client is connected with this AP. Still, if this client is connected with the AP, then also this device is scanning for other available APs. So client machine is keep scanning other available AP. Getting my point? That am I getting any other stronger signal, right? So continuous scanning. Even while connected, the device continuously scans for other available APs and monitor their signal strength. So as you know, how client machine monitor signal strength, guys? With the help of RSSI, right? Received signal strength indicator. So it is going to compare signal. It is scanning for other available APs and it is going to compare the signal strength with the help of RSSI. We talked about RSSI also in the previous video, or maybe we will discuss more about RSSI in upcoming days, right? So hope this is clear that whenever a device is connected with AP, then also it is scanning for other available AP, right, and monitor their signal strength. Then guys, threshold for roaming. See, there is a certain level of signal strength, guys. Certain level of signal strength. If signal will below to that certain level, then your client machine is going to check other APs, that other APs is providing a stronger signal or not. Any other AP is providing a stronger signal. So see, the threshold for roaming is what? When the device detects that the signal strength of the current AP is dropping below the certain threshold, right, indicating that device is moving away from the AP. So if signal strength is dropping, that means client machine is moving away from the AP. So if signal strength will decrease from a certain level, it start looking for a stronger signal from other APs. Getting my point? So this is threshold for roaming, means there is one label of each AP. Okay, and then guys, selecting a new AP. How client machine is going to select a new AP? So first device is connected with AP, then it is scanning for new AP, right, for all other available AP. And if signal strength is dropping from a certain level, then your client machine is going to scan for a stronger signal from other APs. And now how AP is going to select, how client machine is going to select new AP. So the device checks signal strength of the nearby AP. If signal is dropping, signal strength is dropping, that means I am moving away from the AP. Maybe now I am nearby to another AP. So device is going to check signal strength of nearby APs. It selects the AP with the strongest signal, which typically means it is closer or closest, and least obstructed AP. So if a client machine is getting, let's suppose here is the client machine, and guys, I have two AP, AP1 and AP2, right? So earlier AP1 was the closest to this device, but now client machine is closest closest to the AP number 2. That means client machine will get a stronger signal from AP number 2, and this signal strength will start dropping once client will start moving towards AP number 2, or once client will start moving away from AP number 1, signal strength will start getting drop. If you are nearest to the AP, that means signal is more strongest, right? So it select the new AP with the strongest signal. So once this client machine will move toward AP number 2, it will start getting a stronger signal from AP number 2. And once it will start getting a stronger signal from AP number 2, it will send one reassociation message to AP number 2. Reassociation message. Association message is used to connect with AP. Reassociation message means I'm shifting my AP. So next step is reassociation. First step, device is connected with AP, then continuous scanning. After that, if signal strength is dropping from a certain level, then again your client is going to scan for other available APs. That means client is moving away from the current AP. Then it will send what? Reassociation message. So client device send a reassociation request to the new AP. The new AP accept the reassociation message, and device disconnects from the old AP and connect to the new AP. Once new access point is going to accept the reassociation message, client machine will disconnected with old AP and it will get connected with new AP. Again, process is going to be same like we discussed in yesterday class. This process happened quickly to minimize disruption, right? So this is how a client machine is going to shift from one AP to another AP. Now practical example scenario, moving between floors and AP. Let's suppose in a building I have two floors. Suppose here you can see in a building, guys, I have two floors, and at each floor I have one AP, one access point over here and one access point at first floor. So AP1, AP2. AP1 MAC address is this one, means BSS ID of AP1, and AP2 MAC address is this one. This is AP2, this one, right? MAC address of AP2 at second floor. So see, initial connection on first floor, and employees enters the building and connect to the first floor AP, whose BSS ID is this one. The device is within the BSA of AP1, right? This is the geographical area of AP1. That means this is a BSA of AP1. So now my device is here at first floor connected with AP number 1. That means my device is within the BSA of AP1. Moving to second floor. When client will move to second floor, as the employee walk to the second floor, the device continuously monitor signal strengths, and the signal from AP1 weakens. Getting my point? On signal strength will start dropping. That means AP1 signal weakens, and the signal from second floor AP, that is AP2 with BSS ID A, strengthens, right? That means my AP is now getting a stronger signal. Sorry, my client machine is getting a stronger signal from AP number 2 now, right? And is getting weak signal from AP number 1. So once device will start getting a strong signal from AP number 2 and weak signal from AP number 1, it will take roaming decision. It will take roaming decision. Roaming decision means when the device determines that the signal from AP1 is too weak and AP2 has a strong signal, it decide to roam. Means it decide to connect with AP number 2. So roam means moving from one AP to another AP. So the device sent reassociation request to AP number 2. Getting my point? So AP2 accept the reassociation message. Once AP2 will get reassociation message, it will accept and device disconnects to AP number 1 and connects to AP number 2, maintaining network connectivity, and it will happen quickly. Seamless experience. The employee can move freely between floors and different BSAs without noticing any disturbance or disruption in their Wi-Fi connection. So like this, if you have 10 number of floors, at each floors you have multiple APs and all APs are transmitting same SSID. That means you have lots of BSA and client machine can move from one BSA to another BSA. Once a client machine, if a client machine is moving and it will get a stronger signal from any other AP, so it will decide to roam. It will decide to roam. And after deciding roam, client machine is going to send reassociation message to new AP from where it is getting a stronger signal, right? Now guys, some factors in roaming. Factors influencing roaming. So signal strength. Device prefer APs with strongest signal. Then network policies. Like as I told you, AP is going to send capabilities in the beacon signal. So some network uses controller to manage roaming decision and ensure load balance distribution across APs. So these are factors. Okay, so policies or capability, let's say a features is running on AP, on the new AP, which is not supported by your client machine, then your client machine is not going to connect with new AP. So capabilities should be supportable on both devices. Then guys, client device capability. Modern devices have algorithm to manage roaming efficiently. Then overlap of BSA. Yes, BSA should be overlap with each other, right? Ensuring sufficient overlap between BSAs. It helps providing seamless transitions between APs. So each BSA should overlap with each other so that my client machine can roam between one AP to another AP without any disturbance. Now the requirement for automatic shifting. What can be the requirement? So guys, same SSID should be there on each AP. At each access point, SSID should be same. All APs must broadcast same SSID for the network. This ensures that the devices recognize the network as the same, regardless of which AP they are connected to. User experience. Users only need to configure their devices to connect to the SSID once and then will automatically connect to any AP broadcasting that SSID. Getting my point? So a client machine need to connect with one AP, right, which is transmitting same SSID. If a client machine is connected with any AP with that SSID, so it can connect with any other AP as well who is transmitting same SSID, right? We don't need to authenticate the client machine again and again whenever it is connecting with new AP or whenever a client machine is roaming. Then same security setting. So security settings should be same guys on all the APs, like what protocol you are using to authenticate the client machine. So authentication should be same because one client machine is connected with AP number 1 at first floor, right, with WPA2 password. And so if this client machine will move to, when this client machine will move to second floor, so on second floor also I have one AP who is transmitting same SSID, but their security protocol is different, let's say WPA3. So now this client machine is not authenticated with this protocol, this client machine is authenticated with this protocol. So in this scenario, the client machine cannot connect it with AP number 2. So same security protocol should be enabled on both AP guys. Okay, same authentication. All APs must use the same security protocol. It can be WPA2 or WPA3, personal enterprise, and password for the SSID. Password should be also same on all AP. This allows the device to authenticate seamlessly with any AP in the network. And same encryption protocol. Let's say you are using AES encryption protocol to encrypt, then it should be same. Encryption protocol should be same on all the APs. On all the APs, make sure you have enabled AES. So consistent encryption setting ensure that data remains secure as device roam between APs. Then as I told you, overlapping should be there, right? So two BSA should overlap with each other. Very less overlapping coverage area, right? So coverage, the BSA to adjacent AP should overlap to ensure there is no dead zone. Dead zone means the area where wireless network is not available. So that's why two BSA should overlap with each other so that there should be no dead zone. And to provide continuous coverage. This overlap allow devices to detect and connect to the new AP before completely losing the signal from current AP, right? So like if client is moving from one floor to another floor, there is chance that the client machine can disconnect it with the network if there is dead zone. So both BSA should overlap with each other so that to avoid dead zone, and a client machine can connected with new AP without losing the connectivity from current AP, right? Then same network configuration, these are requirement for roaming, seamless roaming you can say. Same network configuration, IP addressing, all APs should be configured to support same DHCP scope or to be the part of same subnet, right? So all APs should be in same network. This ensures that device do not need to obtain new IP address when it move between AP. So if all AP belongs to same subnet, that means client don't need to get IP again from the DHCP server because client machine is still in the same subnet, right? Then guys, VLANs. If VLANs are used, they must be consistent across APs. Means that SSID should be mapped with same VLAN at each floor. For example, the employees SSID should map with the same VLAN on all the APs. Then roaming standard. Roaming standard should also same, right? So all APs should support same roaming standard. We have multiple roaming standards guys like 802.11r, 11k, 11b, right? So see the difference between each. So your AP should support these all roaming standard, and modern AP support these all roaming standards, right? So fast transition, this standard allow device to quickly re-authenticate when moving between APs, reducing latency and improving the roaming experience. So if roaming standard is this one, that means you have fast transition, means AP can authenticate client machine quickly, right? Reducing latency and improve roaming experience. Then guys, we have this standard 11k, radio resource management, help devices discover nearby AP. At this standard help devices to discover nearby APs and measure their signal strength, right? So this standard should also be enabled on all AP so that client machine can discover the AP and measure the signal strength, and then it can compare the signal. Then 11V, wireless network management allow APs to communicate network information to device to help them make better roaming decision. Okay, so as I told you, on the modern AP guys, all modern AP support all these standard. So in a well-designed interface network, AP should support key roaming standard to ensure seamless transition, means seamless roaming, right? Support required, AP need to support this standard to enable fast transition. This standard reduce handoff time by using pre-shared authentication key. Then confirmation, enable 802.11r in wireless controller or on the AP itself. Ensure all AP in the network have 802.11r standard enable, right? So you can read about these roaming standards. It is not much important, but again, if you want to master wireless networking, you have to learn everything. Support required, AP should support this standard to provide client device with information about neighboring AP. So it should be enabled on all the APs to facilitate better roaming decision by client devices. This often involves turning on radio resource management feature in the wireless controller, right? And I have one more standard, that is 11U, internet working with external networks. Support optional. While not always essential, but 11U can beneficial for environment where devices need to switch between different types of network, such as Wi-Fi or cellular. Then guys, benefit of enabling roaming standard on all AP. As I told you, seamless roaming, so client can move from one AP to another AP quickly. We will have less latency, no disturbance. So client experience a smooth transition between APs without noticeable interruption, without noticeable interruption, ensuring a stable connection for application like voice over IP, video conferencing and streaming. Okay, then optimize network performance, improve user experience. After that, see the practical example of a wireless network in building with multiple floors. So suppose there are two types of user at each floor, employees and guest. So you are the wireless network engineer who is going to implement wireless network in a building, and guys, at each floor you have two types of employees, two types of traffic, one for employees and one for guest. So you need to create two SSID. So your SSID can be all APs broadcast to SSID, office Wi-Fi SSID for employees and office guest Wi-Fi for guest. SSID with name, office Wi-Fi, or name can be anything, or office guest Wi-Fi. Then security, WPA2 with same credential for both SSID, right? DHCP, all APs are part of same subnet providing IP addresses from central DHCP server. Then guys, VLAN. So you need to map these SSID with VLANs. So you can map, let's say, office Wi-Fi with VLAN 10 and office guest Wi-Fi with VLAN 20 across all APs. So on all APs you are going to create two number of VLANs, VLAN 10 and VLAN 20. You are going to map office Wi-Fi SSID with VLAN 10 and office guest Wi-Fi with VLAN 20 at each floor on all APs, right? Then guys, roaming process, initial connection, and employees connect to office Wi-Fi on first floor with AP number 1. The device authenticate using WPA3 and receive an IP address from DHCP server. Then moving between floors. So you know how to how a device can shift access point. As employees move toward the second floor, the signal from AP1 weakens and signal from AP2 strength. So the device detect signal from AP2 on the second floor, which also broadcast same SSID and roaming decision. The device measures signal strength and decide to roam to AP number 2 as it provide a stronger signal. Using 802.11 standard, the device quickly re-authenticate with AP number 3 or AP number 2 without noticeable delay, right? So device machine can connect with AP number 2, then seamless connectivity. So in the scenario where a building has multiple floor and each floor with two APs for different departments, let's say employees and guests, your scenario can be anything. So for each type of traffic, you need to create one SSID and you need to map the SSID, that SSID with VLAN. So for first floor with two AP, AP1, AP2. So on both AP, you are going to configure same SSID and you are going to map it in same VLAN like this. So SSID office employee Wi-Fi means for employee, and I am going to map it with VLAN number 10. SSID office guest Wi-Fi for guest, and I am going to map it with VLAN number 20. Now these two clients cannot communicate with each other. Then BSSID for employee is, let's say this is the MAC address of AP1 for employee. Now all APs are going to broadcast to SSID, means to BSSID. Both SSID will have unique MAC address, right? So now as I have two AP at each floor and both are broadcasting to SSID, means both are broadcasting to BSSID also, right? Like this. So this can be your AP1 configuration. BSA1 cover the left side of first floor. Let's suppose this AP1 is connected at left side. So BSA1 is covering left side of the floor and AP2 is covering right side, means BSA2 cover right side of the floor. Now employee can move, you know, the roaming, right? Seamless experience. Now guys configuring a access point, configuring an access point. So to connect an access point, what I can do, see how I can set up a wireless network. See guys, this is my scenario. In my scenario, I have one router. Let's say this router is connected with internet, and then I have one switch, and this switch is connected with one access point, right? And these are the client machine. You can see, I don't know why these machines are connected with AP number 1, this access point. I think this access point don't have any SSID till now. So once I will configure the SSID over here, these devices will get disconnected with AP. See how? Here click on the AP to configure it and then go to config tab. After that go to port number 1 and here you can see the SSID is default, guys. So let's say I am going to set it to office underscore Wi-Fi. This is the name of my wireless network, means what client will see when it will scan for wireless network, then at which channel it will work. So this AP support 2.4 gigahertz, right? And guys, under 2.4 gigahertz we have multiple channels. So by default this AP works on channel number 6. If I want to configure it on channel number 1, I can select the channel. So now this AP is working on channel 1, right? Channel is range of frequencies. So this is at what frequency my access point is transmitting signal. Then guys, coverage area. So what coverage area this AP can support? So around 460 feet. This is in feet. Then authentication. So see here I have multiple authentication, right? Like WEP, WEP key, WPA personal, WPA2 personal, right? So let me configure for now WPA2 personal, and here I am going to set the password. So let's say password is 1 2 3 4 5 6 7 8 9. Let's say this is my password. So I have configured one SSID on this access point and I have set up the password. I have set the security configuration and see the encryption algorithm, that is yes. I have set the password, I have set the SSID. Now if my client machines are going to scan for AP, means by sending probe message, it will discover this AP here, right? So go to wireless section, wireless PC, and here if you will scan, say it is scanning, click on connect and click on refresh. So this client machine can discover the APC. There is one SSID, guys, that is, it is getting one SSID, that is office underscore Wi-Fi. How this client machine have got this SSID? With the help of beacon signal, because AP is transmitting beacon signal. So now client machine can see this name of wireless network, and after that click on connect. So it will ask you for username, means sorry, not username, SSID and password, right? So like this also you can connect it, or directly go to the config tab and then click on wireless 0 adapter interface, right now you can see this machine is getting IP address from APIPA. Right now this machine is getting IP address from APIPA 169.254.83. Where is my pin? Yes, this one. So right now DHCP is not there. So what I am going to do, I am going to set up one DHCP server. So let me do one thing, let me enable DHCP service on this router. So go to config mode and first let me configure F0/0, enable config T interface F0/0 0/0. See, right now if DHCP is not there, this machine can connect it with AP, but it will not get IP address. So here you can go to this wireless 0 interface, and here you can define the SSID. SSID is office underscore Wi-Fi, right? So this is my SSID, and then I am going to put the password WPA2, this one, right? So my password is 1 2 3 4 5 6 7 8 9. So as I have defined the SSID and password, you can see PC1 is now connected with AP, but still this machine is not able to get IP address. Still IP address is APIPA IP address. This is why we don't have any DHCP server. So now I am going to configure DHCP service on router number 1. Say no set to fast Ethernet 0/0 and say IP address. I am going to configure one IP here. Let's say my subnet is 192.168.10.0/24. Let's say this is my subnet, right? So yeah, I'm going to configure one IP 192.168.10. Let's say last IP address from this subnet 254 255.255.255.0. So I have configured last IP address as a default gateway IP address on the router interface. Now say IP DHCP pool, and the name of pool, let's say office underscore Wi-Fi, right? And now say network 192.168.10.0, subnet mask 255.255.255.0, then default router 192.168.10.254. I can define the DNS server IP address also, let's say 8.8.8. And now I need to exclude one IP address which I have configured on router. So say IP DHCP exclude address, that is 192.168.10.254. Now this client machine can get IP address from DHCP server. So please click on this PC and see this machine have still IP address from APIPA. So let me turn it off and let me turn it on again. And now you can see this machine have got the correct IP address from DHCP server, right? So IP address of this client machine is 192.168.10.1. In the same way, if PC2 also want to connect with this AP, here what you need to do, you need to define SSID and password, right? You have to enter SSID and password. So go to wireless PC and then scan for available network. Here you will see the SSID. Here you can see the SSID office underscore Wi-Fi. So click on it and click on connect, right? So security is WPA personal and password is 12345567889, right? So my SSID is office underscore Wi-Fi and password is 129, and let's click on connect. And now you can see PC2 is also connected with AP. And here what I can do, I can show you the IP address. So simply say ipconfig. Now you can see the IP address of this machine 192.168.10.2. So this machine have got this IP address from DHCP server, and default gateway IP address is 192.168.10.254. In the same way, PC3 can also connect with AP. Go to wireless interface and scan for available wireless network. So you will see this network, click on it and connect. It will ask you for password, so provide password 123456789 and click on connect. Now this machine is also connected with AP, and this machine will also get one IP address from DHCP server, IP config. So this machine have what IP address 192.168.10.4, 10.1 to PC1, 10.2 to 10.2 to PC2, and 10.4 to PC number 3. And now these PC can communicate with each other with the help of access point. Like from PC1 you can check, from PC1 you can ping to PC2, ping 192.168.10.2. see, I am able to ping PC number 2. In the same way I can ping PC3 also, ping 192.168.10.4, right? And I can ping my default gateway also, and then I can access internet as well, ping 192.168.10.254. see, I am able to ping my default gateway as well, right? So this is how to set up a wireless network, basic wireless network. Again, now if you have two traffic, then you need to configure two SSID on this access point, right? Then guys, VLAN configurations are there. So day by day we will see the rest configuration. Like here I can put one authentication server who is going to authenticate this user. So in upcoming days we will see those all configuration. Okay, so if I will talk about the configuration of an access point, so connect the router and switch with the help of Ethernet cable. Then connect switch to access point with another Ethernet cable. Connect a laptop or a smartphone to the access point wirelessly. Configure the router, means configure DHCP. Set up IP address on router interface connected to switch. Enable DHCP to automatically assign IP address to the wireless clients. Configure the access point, means configure SSID. Assign an IP address to access point, right? So in my scenario, my access point have also one IP address, right? Access point will also get one IP address from guys DHCP server, right? And then you can manipulate these things also, like it is working on half duplex, so you can tell your AP to work on full duplex, right? So let me click on full duplex. Now you can see link between access point and switch is goes down. So on switch numbers, on switch also I can configure this interface as fast Ethernet, sorry, on full duplex, to work on full duplex. By default it work on auto 0/1, say duplex full. Now again it will come up. Now you can see, right? Then set the SSID for wireless Wi-Fi network name. Choose the security setting. You can configure. Again, we have multiple security protocols guys for wireless networking. We'll see it in upcoming videos. Then select the PCs and select the SSID, then provide the password, and then you can connect your machine with AP. Setup plan. How to set up the AP? So guys, as I told you, to set up a wireless network, first you have to site survey, means you have to find the places where you are going to place the APs, right? So placement of AP is important, right? So identify coverage area, then determine area that need Wi-Fi coverage, calculate the number of APs, how many APs are required, right, to cover all areas. Let's say in a building, in a big building, you are going to implement wireless network. Okay, then security configuration, channel plannings, these are very, very important. Okay, so we'll discuss more about access point, guys, in next video, because the length of this video is already 45 minutes. Okay, so today we discussed like roaming process in wireless networking, how a client machine moves from one AP to another AP. Guys, if you have learned something from this video, please hit on like button. If this video is helpful for you, if you want more videos like this, please type yes in the comment section. Once you will type yes in the comment section, I will get to know these videos are helping you a lot, right? So it will motivate me to make more videos. That's all for today. We'll meet soon in next video. Till then, stay safe. Bye bye, guys. That's all for today.